All right, so now we have made it to level 2, video number 2. Reminder that there's 3 videos in this level. And we are going to be graphing equations and then identifying a solution to each. Now, numbers 1, 2, and 3, hopefully you recognized that these 3 equations are in slope-intercept form because we have y isolated. They are in the form of y is equal to mx plus b. So, what we need to graph these equations is we need our slope, we need our y-intercept. When graphing an equation in slope-intercept form, you start with your y-intercept. So, in number 1, my y-intercept is -4. I'm going to plot that point -4 on my y-axis. That's right here. And then, from that point, we use our slope and we graph our rise over our run. So, with this slope being negative, a reminder that we've learned in a previous lesson that it does not matter where that negative is written. For example, we could have had it as a -3 over a 2. Or your slope could be written as a +3 over a -2. If I were to graph a slope of -3 over +2, then from my y-intercept, that means I would go down 3 and over 2 units to the right, and this would be my next point on the graph. Now I'm going to require you to have at least 3 points on a graph. So, maybe you want to use this slope of +3 over -2. From my y-intercept, I could go up 3 and over -2 to find another point on the graph. If you wanted to continue to graph more points, we could go up 3 again and over -2 to get another point on the graph. And you can keep using that slope to keep graphing points on your line. And so this is what your line looks like. Now, when I say identify a solution to each equation, your solution might be different than my solution. All I am looking for when I say a solution to each equation is I'm looking for you to identify one point on your line. So maybe this dot that I just highlighted in pink, maybe that's the solution you will give me. We write our solution as an ordered pair. That point that I identified is -2, -1. But maybe you wanted to use the yellow point. So if you chose the yellow point, your ordered pair would be 2, -1, 2, 3, 4, 5, 6, 7. You would have the ordered pair 2, -7. It's up to you what solution you want to provide, but what you need to do is you just need to pick a point that is on the line. All right, so you may not have had the same solution that I wrote down, and that is okay. All right, so number 2, we start again with our y-intercept. In this case is a +2, so on my y-axis, I'm going to graph a y-intercept of +2. Then I'm going to complete my slope, doing rise over run. So I have 1 over 2 as my slope, so that means I go up 1 and over 2 to the right, and I can continue that, up 1 and over 2 to the right, but I do want to show you how I could go the other way from the blue point. Another way to write a slope of +1/2 of +1/2 would be to write a -1 over a -2, because a -1 divided by a -2 is a +1/2 slope. So from your blue dot, you could have also went down 1 and over 2 to the left, down 1 and over 2 to the left. It's up to you. I'm only requiring you to have 3 points on the graph, but I wanted to make sure that you guys were aware of how to graph this, either going to the right of the blue dot or the left of the blue dot. And this is what your line should look like. All right, now we need to identify a solution. You just need to pick an ordered pair on this line, a point on the line. Maybe you want the blue point. The blue point is the ordered pair 0, 2. That would be a solution. Now, if you picked a different point from me, that is completely okay. All right. But the point needs to be on the line. All right, so number 3, we start at our y-intercept, which in this case is -2. Oops, it keeps jumping on me. There we go. So I'm going to plot a point on my y-axis at -2. And now I'm going to graph my slope. Now my slope is not written in rise over run format. To get it into rise over run format, you can always write a whole number over the number 1, because 3 divided by 1 is 3. So those are equivalent. 3 and 3 over 1 are equivalent. So my rise here would be 3, meaning I go up 3. My run would be 1, meaning I go over 1. And you can continue that, up 3 and over 1, up 3 and over 1. Or you could have written your slope as a -3 over a -1, and you still get a +3 slope in that situation. In that situation, we would have went down 3 and over -1, down 3 and over -1. Notice that regardless of what slope I used, I do get the same trend. This trend of my graph is linear. It creates a straight line. And now we're going to identify a solution. It is completely up to you what point you chose. Maybe you're going to choose this point here that I'm highlighting in yellow, which is the point 1, 1. But again, it does not matter which point you choose, as long as it's on the line, that would be a solution. All right, 4 and 5, we want to graph the following equations, and we want to figure out are the following point solutions to each equation. Now, number 4, another way that you could write this is y is equal to 0x plus 5, because 0 times x is 0, and we would just be left with the equation y is equal to 5. Or you don't have to write your equation like that. You could recognize that when you have y is equal to a number, what that means is on your graph, your y value should always be 5. So at an x value of 0, y should equal 5, because that's exactly what this equation says, y equals 5. When x is 1, y is 5, because again, the equation says y is equal to 5. When x is 2, y is 5. When x is 3, y is 5. Notice the trend. It looks like it is creating a horizontal line. So what do you think if the equation was x is equal to 5 would be? Think about that. But that's just something that you guys are going to think about and maybe apply later. So whenever you have y is equal to a number, it's always going to be a horizontal line crossing the number that it is equal to. And now we're going to identify, are the following points solutions? Well, let's look at our graph. Is the point 1, 5 a solution? Bingo, it is. So yes, because it lies on the line. Is the point 5, 3 a solution? No, because that's where it lies. It's not on the line, so it's not a solution. Another way that you could do this is how we did this in our last lesson. You could put x and y into the equation to determine if it's a solution. All right, looking at number 5, we are now going to graph this. So I'm going to, my y-intercept, it is in slope-intercept form. My y-intercept is 3. And my slope is -2. A reminder, we can put that over 1. So that means I go down 2 and over 1, down 2 and over 1. Or we could have written it as a 2 over a -1, meaning I go up 2 and over -1, up 2 and over -1. So this is what your equation looks like, or your line looks like. Now we want to identify if these points are solutions. 1, 1, well 1, 1. That's this yellow point that I'm highlighting on the line. So yes, it is a solution. Now 15, -27 is not on the graph. So that's not an automatic no. It could be a solution, but we just can't see it on the graph. Remember that these lines have arrows, meaning that this line continues on even off the graph. So to find out if this point is a solution, we will need to put the x and the y value into the equation that's given to us. So I have a 27 is equal to a negative 2 times a 15 plus a 3. So I have a 27 is equal to a negative 30 plus a 3, which unfortunately is a 27 equals negative 27. So these don't equal each other, so in fact this is not a solution, but it's not because that it's not on the graph, or it's not because that it doesn't fit on this graph. This point is eventually, if this graph kept on going, it would be on the graph, it just wouldn't be on the line. All right, and when I say graph, I'm talking about it could be, you know, on this actual graph here, just not on the line. All right, moving on to the next page. This time, now we have in our equations in point-slope form. A reminder that it's easy to find a solution in point-slope form because we have a point within our point-slope form equation. Remember, the x value is the opposite of what it looks like. It looks like a negative 2. It's really a positive 2. The y value is an opposite of what it looks like. It looks like a negative 1. It's really a positive 1. That does not need to be your solution, though, but I wanted to remind you that there is an ordered pair or a solution within your point-slope form equation. And now, what we're going to do to graph a point-slope form equation is we're going to graph this point 2, 1, because that's a point that lies on the line. And now we're going to use the slope 2/3 to graph the rest of the line. So I can go up 2 and over 1, 2, 3. I can keep going like that, or you could have written your slope as a negative 2 over a negative 3, because that's the same thing. Going down 2 and over negative 3, this is what your line would look like. And if you wanted to use a different solution, like maybe you wanted to take this point here, this yellow point, and write down the solution negative 1, negative 1, that would have been okay. But for me, in point-slope form, it's really easy to write a solution. For example, number 7, one solution would be negative 2, positive 4. Because I know that there is a solution within point-slope form equation. So I'm going to start off by graphing that solution, negative 2, 4. And now I'm going to use my slope. My slope is 3, or I can write it as 3 over 1, which means I go up 3 and over 1, and I can keep going up 3 and over 1. Or I could have written it as a negative 3 over negative 1, and I could have went down 3 and over negative 1. It's up to you. And then the next one, number 8, again, a solution is already in this equation, 6, negative 1. We can start with that. 6, negative 1. Oops. It jumped on me. And then now I have a slope of 1/4. So that can mean I go up 1 and over 1, 2, 3, 4. I'm not going to allow you to go off the graph, so you would need to do a negative 1 over negative 4 slope to graph the rest. All right, so here is your line. Another way you could have done these is you could have put it into slope-intercept form. Remember, putting an equation in slope-intercept form, all you need to do is isolate y. And then once your equation is in slope-intercept form, you could have graphed it like numbers 1, 2, and 3. So it's up to you. All right, and then number 9, we're going to do this one. So I'm going to start, you could put this in slope-intercept form if you wish. I'm not going to. I'm going to start with the point negative 3, 2. And now I'm going to graph my slope of negative 2, which would be negative 2 over 1. Down 2 over 1, down 2 over 1. I want you to use the equation to see if any of these are solutions. Pause the video, try it, then resume to check. And here are your answers. A reminder that all linear equations have infinitely many solutions.